Hello students, welcome to Senior College Mathematics. Topic of discussion is bearing. Lesson 5, location of a point from another, that is reversed bearing, part 3. And we have example 16. In the diagram, PQ is equal to 8 meters, Q arrow equal to 13 meters. The bearing of Q from P is 50 degrees and the bearing of arrow from Q is 130 degrees. A part of the question: calculate correct to 3SF, Roman figure 1, P arrow. That is the length, P arrow. Roman figure 2, the bearing of arrow from P. B part of the question: calculate the shortest distance between point Q and P arrow. That must be the height of the triangle. Hence, find the area of triangle PQ arrow. This question is very simple because you have the diagram already. For us to find P arrow, this entire angle is needed because from here to here is 50 degrees. Here is also 50 degrees. That is alternate angles. The whole of this side is 180. If from here to this point is 130, the remaining angle must be 50 degrees, so that this entire angle, angle Q, is 100 degrees. And you can obtain P arrow using the cosine rule. The solution continue. You already have the angle here, as I have explained earlier, 100 degrees. We have to label the side. This is side arrow facing angle arrow. This is side Q facing angle Q. This is side P facing angle Q. Then we state the cosine rule in terms of the unknown side, that is P arrow denoted by Q. So you have P arrow squared, that is equal to Q squared, is equal to P squared plus arrow squared minus 2P arrow cos Q. Next, you replace the known sides and angle with what they stand for. You can use your calculator to check cos 100 degrees directly, and you are going to have this value. You have this value is going to be in negative form. But assuming you don't have a scientific calculator, you have only 4-figure table, and you must do this. In the 4-figure table, 100 degrees is not there, so you have to look for the equivalent of this value. 100 degrees is in the second quadrant where cosine is negative with this formula. So to get the equivalent of 100 degrees that you can check in the 4-figure table, you have to subtract the given angle from 180 degrees. And because cosine is negative in the second quadrant, you have to attach negative sign, and you have minus cos 80 degrees, the equivalent of cos 100 degrees. You continue with the simplification. 13 square is 169 plus 8 square 64. minus, if you multiply these three numbers, you have 208, then the equivalent of cos 100 degrees. If you add, you get this result. Minus times minus is plus, then you have it in this form. If you check cos 80 degrees, you have this result. If you multiply here, you have this result. You add to this number and you have this result. To get Q, which is P arrow, you have to take the square root of both sides, and you have it to be 16.4045. To 3SF, you have 16.4 meters as the length of P arrow. The next question is to find the bearing of arrow from P. To do that, you go to P, you start movement from the north to that line that join P and arrow together. So from here to here is 50 degrees. We need this remaining angle denoted by theta. Once you obtain theta, you add it to 50 degrees. That gives the bearing of arrow from P. Roman figure 2. To find the bearing of arrow from P, go to point P. The bearing is 50 degrees plus theta, as I have said. So theta is needed, which is by the application of sine rule. To use the sine rule, you need one complete side in terms of angle and the side facing it. That must be Q. We know angle Q and side Q. So the side facing angle theta is P. So you state the sine rule in this form. P is 13 over sine theta equal to Q is 16.4 over sine Q. That is sine 100 degrees. To make sine theta the subject, you have to cross multiply and divide both sides by 16.4, and you have this result. After simplification, you have this result, and after division, you have 0.7806. To get theta, you check the inverse of cosine of both sides, and you have it in this form. Theta becomes 51.3 degrees. So the bearing of arrow from P is 50 degrees plus theta, which is 51.3 degrees, and that is 101.3 degrees. B. The shortest distance between Q and P arrow will be the triangle PQ arrow altitude, or the perpendicular height. So in the given diagram, you extract out triangle PQ arrow. So from Q, you are moving to P arrow. You have to pass through this direction, which is the height of the triangle. From the previous diagram, this angle is P, which we obtain as this. This angle is given to you 100 degrees. This side is 8. This side is 13 meters. For us to get the height, we have to consider triangle PTQ. The height is the opposite to this acute angle. Then this is the hypotenuse. You must have sine 51.3 degrees equal to opposite TQ over hypotenuse PQ. That is h over 8. Multiply through by h, multiply through by 8 to clear fraction. You have it in this form. After simplification, you have this and this. To 3SF, you have 6.24 meters as the shortest distance between Q and P arrow. Hence, we are asked to find the area of triangle PQ arrow. You can obtain the area in various forms. You can use half times base times height, the popular formula. Also, when you have two sides and the angle between them is given, you can as well find the area in that direction. You have side arrow, you have side P, and the angle between them is 100 degrees. You have the area in this form. 1/2 times P arrow sine Q. You have it in this form. Divide 8 by 2. You have 4. We are left with 13 times 4 times the value of sine 100 degrees. That is 0.9848. After multiplication, you have this result. To 3SF, you have 51.2 square meter as the area of triangle PQR. Example 17. In the diagram, 3 points A, B, and C are on the same horizontal ground. B is 15 meters from A on a bearing of 0.53 degrees. C is 18 centimeters from B on a bearing of 161 degrees. A vertical pole with top T is erected at B such that angle ATB is equal to 58 degrees. Calculate correct to 3SF. A part of the question, the length AC. B part, the bearing of C from A. C part, the length of the pole BT. So the first part is to get AC. You must note the given units. They must be the same. So since distance is measured in meters, the standard unit, let's convert this to meters. To do that, you divide through by 100, noting that 1 meter is equal to 100 centimeters. That is 1. So to get AC, the whole of this angle is needed. From here to this point is 0.53 degrees. So this angle is also 0.53 degrees. The whole of this side is 180. If from here to here is 161, this remaining angle must be 19 degrees. So when you add it to this, you have the entire angle to be 0.72 degrees. So that to get AC, you can use cosine rule since we have two sides and an included angle. The solution continues. You have all the angles marked out. This side has been converted to meters and you have 0.18 meters. To get the length AC, it is by cosine rule. If you label the various sides, here is side B, here is C, and here is A. So you have B squared equal to A squared plus C squared minus 2AC. Here should be 2AC cos B, cos B. So B square is equal to, what is A square? 0.18 square plus C square, that is 15 square, minus 2 times AC in this form times cos 72 degrees. If you simplify, you have this results. Square of this is this 15 square 225. You multiply these three numbers, you have this result. You check cos 72 degrees, you have this result. If you add these two numbers, you have this result. You multiply these two numbers, you have this result. After subtraction, you get this. To get B, which is length AC, you have to take the square root of both sides, and you have 14.9 meters to 3SF. That is A part. B part of the question, the bearing of C from A. C from A. You go to point A and you start from the north to that point that joins A and C together. That is 0.53 degrees plus theta. That is the required bearing. Theta is needed, which is obtained using the theorem on complementary angles. What you have here is a quadrant, and the angle there is 90 degrees. So if you add the two angles, the sum is equal to 90 degrees. Theta becomes 37 degrees. So the bearing of C from A is 0.53 degrees plus 0.37 degrees, and that is 0.90 degrees. C part of the question, we have to find the length of the pole BT. In triangle TBA or ABT, this angle, this symbol means 90 degrees. So you have a right angled triangle. This becomes hypotenuse. We are to work with this acute angle. This side is opposite, and BT, the length of the pole, is adjacent. So you have tan 58 degrees equal to opposite AB over adjacent BT. You have this result. If you multiply through by BT to clear fraction, you have this result. Divide through by tan 58 degrees to make BT the subject, you have this result. After simplification, you have this. After division, you have this. And to 3SF, you have 9.37 meters as the length of the pole BT. Example 18. The diagram below shows the positions of two shifts G and K relative to harbor H. You have the diagram. K is 8 kilometers on a bearing of 290 degrees from H, and G is 10 kilometers on a bearing of 0.50 degrees from H. A part of the question, determine angle KGH. B part, calculate correct to 1 decimal place. Roman figure 1, the distance KG. Roman figure 2, the bearing of H from K. The bearing of H from K. Roman figure 2, again, the bearing of H from K. Solution. The given diagram needs to be adjusted in order to get angle KHG so that the distance KG can also be obtained. So let's come here and indicate the 4 cardinal points. The bearing of K from H, you go to H, is 290 degrees. You start from the north to this point, that is 270. When you get here, it becomes 290 degrees. That is what you have from here to this point. And the whole of the quadrants is 360 degrees. If from here to this point is 290, for us to have 360, this remaining side must be 070 degrees. Then secondly, the bearing of G from H is 050 degrees. You go to the same H, you start from the north, you move 50 degrees, and that is to G. So the whole of this angle KHG, becomes 070 degrees plus 050 degrees, and that is 120 degrees. So A part is done. B part, you have to find the distance KG that can be denoted by H. This is G and here is K. You have the other two sides. The angle opposite this side is known, so cosine rule can be used to get the distance KG before the bearing. Now the bearing of H from K, you go to K, you start moving from the north to this point, that is 90 degrees, one quadrant, you extend to this point, so this angle is needed. So once you get this angle, you add it to 90 degrees and you have the bearing of H from K. The solution continues. Already we know angle KHG to be 120 degrees. We move to B, Roman figure 1. Distance KG can be obtained using the cosine rule stated in this form. So this side KG is small letter h. This side facing angle K is small letter k, and this is small letter g as you have it. So h squared is equal to 10 squared plus 8 squared minus 2 times 10 times 8 times cos 120 degrees. You have this result. If you are to go by 4-figure table, 120 is not there. Its equivalent is minus cos 60 degrees. So when you add these two values, you have this result. Now minus times minus is plus. You have 160. If you check cos 60 degrees, it is 0.5. So you have 164. You multiply these two values, you have 80. After addition, you have 244. To get h, the distance kg, you take the square root of both sides, and that is 15.62049, and that is 15.6 kilometers to either 3SF or 1 decimal place. Roman figure 2, the bearing of h from k, it is 90 degrees plus theta. From here is 90 degrees to this place denoted by theta. Theta is needed and it can be obtained using the sine rule, because we know this side and the angle facing it. This needed angle, the side facing it, is also known. So to use the sine rule, you need one complete side. That is the side and the angle opposite it. So we start with 10 over sine theta equal to this side 15.6 over sine 120 degrees. That is what you have here. To make sine theta the subject, you need to cross multiply and divide both sides by 15.6. You have this result. After simplification, you have this, and after division, you have sine theta is equal to 0.5551. To get theta, take the inverse of sine of both sides, and you have 33.7176 degrees. Therefore, the bearing of H from K becomes 90 degrees plus 33.7176 degrees, and that is 123.7176 degrees. To one decimal place, you have 123.7 degrees. End of lesson 5. Thanks for watching and learning. Don't forget, watch out for more from the voice of Peter Kos. Lastly, if you are not safe, your life is in crisis, your life is in trouble. To avoid all of that, you have to give your life to the Lord Jesus Christ and confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Be good to yourself, stay out of trouble, study your books, do the needful at all times, flee every appearance of evil, don't defraud others to make money, find something good and genuine to do with your hands and your brain, and the Lord will bless you. Goodbye and stay tuned.